fine. So in the previous class, we were talking about decimal numbers and how different types of decimal numbers represent either rational or irrational numbers. So all of you recall that?
Yes, sir.
Okay. So just a very quick recap. So tell me, if I have a rational number, that means it can be represented in the form of p by q. So any fraction, what you see, any fraction, some big number, small number, whatever you see, 3 by 8, 784 by 3856, whatever. Any fraction you see, it is a rational number, right? So if something is a rational number, what kind of decimal expansion it can have?
Terminating.
It can either have a terminating decimal or if it is not terminating, that is, if it is non-terminating, it has to be recurring. Okay, so when some fraction is given, this is what you need to decide whether the fraction will have a terminating decimal or a non-terminating decimal. Okay, so Bhavani, why have you joined now? Okay. Yeah, so what I was saying is, if you're given some fraction, whatever it is, you will have to decide whether it has a terminating decimal or non-terminating decimal. So we talked a little bit about this yesterday. So what is the rule? If you have been given any fraction, like let's say 3 by 8, how do you decide whether this one has a terminating decimal or non-terminating? Which one?
Non-terminating.
Okay, why is it non-terminating?
Because it is not in the form of 2 power m into 2 power 5 power n.
Okay, actually, that is not correct. Let's see how. See, if you should look at only at the denominator, right? You remember that, all of you? You only have to look at the denominator. So if you look at the denominator, how can you factorize this? So you know that it can be written as 2 to the power 3. Now, can you not see that it is in the form of 2 to the power m and 5 to the power n?
Sir, 5 to the power 0, sir.
Yes, of course. There is a 5 to the power 0 and anything to the power 0 is 1. That's why this 5 is not visible over there because n is equal to 0 for this case. But it is in this form, right? And see, that is not the thing anyway. So you should remember, I told it very clearly yesterday, you do not have to have all 2 and 5 both. It's not necessary to have 2 and 5 both over here. Any one should be there. Both are there. That is also okay. As long as it does not have any other prime numbers like 3, 7, or anything else. Not 5. Any other number other than 2 or 5 should not be there in the denominator. So that is not there. That means it will have a terminating decimal. You can check it also. Do the actual division. Tell me what is the decimal expansion of 3 by 8? Or instead, you can use the trick which I showed yesterday. 2 to the power 3 is there, so you'll have to multiply 5 to the power 3, and same 5 to the power 3 will multiply in the numerator also. So this becomes 125 into 3. How much is that? 375, is that right? And this will be 2 to the power 3 into 5 to the power 3 means it will be 10 to the power 3, which is 1000. So it will be 0.375. So it's a terminating decimal, right? Everyone is okay with this? Quickly confirm.
Yes, sir.
Yes, sir.
Okay. Fine. So all these numbers, what you see here, the denominators are, when you factorize them, either they will have a 2 or 5. That is, they will be in the form of 2 to the power. Just a minute. Yeah. So for a terminating decimal, what should happen to the denominator? Two to the power m and 5 to the power n. It should not have any other prime factors other than 2 or 5. So quickly confirm, all of you, do you understand this rule or this theorem?
Yes, sir.
Okay. So let's take this example. And you have 625. So tell me, what is it? Is it terminating or non-terminating? When I say non-terminating means it should be non-terminating. Recurring, of course, it cannot be non-recurring. You should understand that from the yesterday's class. I explained that yesterday. So tell me, guys, what is it?
Terminating.
Yes. So what is the decimal? What is the prime factorization of 625? What did you get?
5
5 to
power
the power 4, sir.
5 to the power 4. Excellent. And how many places of decimal will it have?
4.
Yes. Whatever is the higher power of 2 or 5. Okay, whatever is the higher power, like 2 has a power of 0, 5 has a power of 4. So whichever is the higher power, that many places of decimal will be there in this expansion. Okay, so without doing any calculation, the moment you see that 5 has a power of 4 and 2 has a power of 0, nothing. So 4 is the higher power. It simply means that the decimal expansion of this number it is terminating. And how many places of decimal has? It has 4 places of decimal. Is this point also clear to everyone? The point which I just made, looking at the power of the 2 or 5 and then deciding how many places of decimal it will have. Is that clear to everyone? So if there is some fraction, like let's say 137, there is a 2 to the power 3 and 5 to the power 5. So how many places of decimal will be there in this?
5.
Yes, it will have 5 places of decimal. You can check it. Convert this to decimal quickly.
Zero point 0.0137.
Okay, is that right, guys? Everyone is getting this? But this has only 4 places of decimal. You people said it should have 5. So this cannot be right, no?
Sir, is that dot, the point is not counted?
No, of course, point is not counted. Number of places of decimal means 4 digits are there. That you should count. It should have 5. Okay, the number of digits should be counted after decimal, not the decimal itself.
Yes, sir.
Okay, but I have taught you how to convert this to decimal, no? What we have to multiply here? See, 5 to the power 5 is there, 2 to the power 3 is there. So 3 is lesser than 5. So of course, to make both of
2
them,
square.
yeah, you have to multiply with 2 square. So this 2 square into 2 to the power 3 will become 2 to the power 5 into 5 to the power 5. This is
0.005.
yeah. But if you multiply 2 to the power 2 in the denominator, same 2 to the power 2 you have to multiply in the numerator also. So don't forget to multiply the 2 to the power 2, which is 4. So 4 times of this number, how much is that? What should be the numerator? Yes. And then no need to do any conversions. You know that it will be 10 to the power 5. So the decimal will be before 5 places. So just write 548 and then make sure that there are 5 places of decimal and put a decimal before that. So it should be 0.00548. So tell me if you people understood this. You had to add 2 more 0 to make sure that it gets 5 places of decimal. And don't forget to multiply this 2 to the power 2 to make it both equal same power. So 3 is there, you have to add 2 more. That's why we did 2 to the power 2 multiplication. Is it clear, guys? Give me a confirmation, yes or no? All of you.
Yes, sir.
Okay, I got a confirmation from Ritesh. What about other people? Was that Ritesh or Hari? Who was that?
Hari, sir.
Hari, okay.
Yes, sir.
Yes, sir.
Okay, fine. So, fine, that's good. So let's get going. Let me give you one more example quickly. So let's say if you have this number, 59 divided by how many places of decimal it will have?
6.
Yes, the moment you look at the higher power, it will you
Six,
should
sir.
be able to decide it will have 6 places of decimal. Then do the conversion also and tell me what should be the decimal number.
Done, sir.
Okay, tell me what's the answer.
0.000944.
0009.
944.
Okay. So at least it has 6 places of decimal, so looks correct. What about other people? What answer are you getting?
Sir, same, sir.
Okay. Anyone needs help with this? Anyone wants me to solve this? Okay, so I hope everyone is able to do this. You should be able to decide how many places of decimal it will have also, and you should be very quickly able to convert it into a decimal also using this method, not by actual division. Don't sit and start doing actual division, okay? You do not have to do that. Right, so if anybody needs help with this, you'll have to ask me, okay? I'll assume that you understood this because nobody is speaking, so I'll continue. So let's move on to the exercise basically. Yeah, so we have seen so many other things. All the terminating decimals we have seen, but we have not seen examples of the non-terminating ones. So let's say I have a number which is 1/7, very simple. Again, understand that 1/7 means the denominator is not in the form 2 to the power m and 5 to the power, and there is some other prime number 7 has come over here. So the decimal expansion of this number, it will be non-terminating. And since it is a fraction, we know that it is a rational number. If it is non-terminating, of course, it has to be a recurring, non-terminating recurring number. So you can check that. Try doing the division. Do this division and check. All of you. Everybody knows how to divide this number, no? Convert this to a decimal and tell me what is the answer.
Sir, I got 0.1421.
So 0.1428.
0.1428. Nitya, what about that? You were saying after that what?
0.1421, sir.
1, and then after that? Did it stop? Did it terminate? Or did you get a remainder 0?
I got the remainder 0, sir.
0. This means it will be terminating decimal, but that's not possible. No, just now we have learned the theorem that if any other prime number comes other than 2 or 5, it should have a non-terminating and recurring decimal expansion. This is not possible.
Sir, it's 0.14282828 like that it continues.
Sorry, sir, I did the
282828 like that.
Yes, sir.
Okay. So see, 7 is here. There's 1. 1 is already smaller than 7. So you can't do the division. So what do? We put a decimal.
Sorry, sir, I did it.
Yeah, it's okay, no problem. Making a mistake is not a problem. Never be sorry for making mistakes. Okay. Yeah, so 1 is smaller than 7. So what do? We put a decimal. And then once you put a decimal, you are free to put a 0 over here. Now this is 10. So we can put it as 7 ones are 7. 3 is the remainder. And you should know that if we have put a decimal without doing anything, free of cost, we are allowed to put a 1 0 over here, not more than 1. 1 0 we can put it. So now 3 becomes 30. So 7 4s will be 28. 2 is the remainder.
There is
Again,
not.
yes, tell me.
It's not coming 2828. It's coming what 0.14285714.
Okay, let's see. That's what. Okay, So what are you
Sir, I
getting?
also got the same only, sir.
One. What did you get? Deep, first, Deep, confirm me. What was your answer, Deep?
0.14285714.
Like this? Okay. It keeps on going like this.
Same, sir.
Yes.
Okay. Hari is also getting like this.
Yes, sir.
Okay. Who else?
Me too, sir.
Pragati, is that you?
Yes, sir.
Okay. So Deep, Pragati, and Hari are getting this. What about other people? What is the answer you guys are getting? This one or this one?
Sir,
Sir, the
Second
second one
one,
is right, sir. I also got the same only.
Okay, so Ritesh is also getting this. Okay, let's see. Let's see. So we were up to 2, right? So anyway, now we are allowed to put one more 0 over here. So 2 will become 20. So 7 2s are 14. 6 is over here. 6 will become 60. So 7 8s are 56. So we get a 4. That becomes 0. 7 5s are becomes 35. So there is a 5 over here. Then it becomes 50. So 7 7s are 49. And then you see you got a remainder 1. Remember, we started with 1 in the beginning. So don't you think after that it's going to repeat the same story again?
Yes, sir.
So just to make sure that everybody understands, let's do this. So this is the number which we have got so far. And after this, we have got a 1 over here. Let's see what numbers we get. See, 1 is there. Again, we'll make it as, let me use some different pen. So 1 will become 10 now. So again, 7 ones are will go 7. You see, same remainder 3 is coming. Just like this one over here, 3. Now it becomes 30. We'll put the same 4 over here, 7 4s are 28. 2 will, just like that, we got a 2 here. So it become 20, and again it will go 7. 2s are 14. So you see, this number is going to repeat now. 142,857. 142,857 will keep on repeating. Again, 142,857 will come. It will repeat. Is everyone able to follow what's happening here? So this is a non-terminating number. Same numbers will keep on coming. And what is the digit which is repeating? It's not just 1 digit or 2 digit. It is like 1, 2, 3, 4, 5, 6. These 6 digits are repeating again and again. 142857. 142857. This will keep repeating. So what did we understand from this? When you divide 1 by 7, what do you get? So what is 1 by 7? 0.142857 with a bar on it.
Yeah.
So this is a non-terminating recurring decimal. Why did it happen? Because the denominator was not in the form of 2 to the power m and 5 to the power m. There was some extra, some other prime number other than 2 or 5, which came over here, which was 7. It could not even be cancelled with the numerator. 7 could not be cancelled with the numerator also. That also you should just verify once. Can I cancel 7 with something in the numerator? So here, of course, it is 1 by 7. You can't do anything. So okay, quick confirmation, guys. Everyone is okay with this non-terminating recurring decimal?
Yes, sir.
Yeah. And you should not stop so early. You should think. I think you people would have learned one theorem, no? If the denominator is 7, the maximum number of digits in the repeating block can be up to 6. You remember that? We studied that in the previous class. So the number of digits in the repeating block is at least less than 7. If it is a denominator is 7, it should be less than 7. if the denominator is 1 by 15, let's say. So if it had it will have a repeating block. So it can have up to a maximum of 14 digits in the repeating block. Maximum, not always. It will not always have 14 digits like that. It may have up to 14 digits. So you should check, keep on dividing until you get to 14 digits to make sure that it is repeating or not. That is why. See, if people had stopped over here itself, they would have thought, okay, some different number is coming every time. So maybe this is non-recurring number. But that's not the truth. You had to go up to 6 digits at least to make sure that it is repeating or not. All right. So enough of stories. Now let's get back to the questions from your exercise. So take up this exercise, first question, and work on the first 4 questions very quickly, all of you. So in this question, all you have to do, you don't have to convert them to decimal. They're only asking whether to state whether the following will have a terminating decimal or non-terminating repeating decimal. That's all you have to tell. Repeating means recurring, you should remember, okay? So non-terminating repeating is the same as non-terminating recurring. So I will solve that first question. If anybody needs help, you can see, otherwise do this on your own. Exercise is it 1.4. Question 1, first part. So what do we do? Go to the rough work and find the prime factorization of this number. So this is basically 5 to the power 5.
Completed, sir.
Okay. Which one? First one or all 4?
All 4, sir.
Okay, very good. So let's wait for others. Or maybe if you want, you can continue with the remaining questions. Anyway, you have to do this in home over the weekend. So while you have time, you can continue doing the remaining problems. So I'm waiting for you people. Tell me when you're done with the first 4 questions.
Completed, sir. Completed, sir.
Okay.
Completed, sir.
Okay, good.
Completed, sir.
Okay. Anyone has any trouble? Anyone wants help with any questions?
Third one, sir.
Third one. Okay, let's see. 64 by 455. Okay, sorry, before that I stopped in the middle over here, I think. So it has this first question, 13 by 3125. What happened? What kind of decimal expansion this has, guys?
Terminating.
Yes, it will have a terminating decimal because it is of the form 2 to the power m into 5 to the power n, where what is the value of m over here? M is 0 this time because 2 has a power of 0. So we can say that m is 0 and n is equal to 5 here. Okay. And one extra question. So this question only asks you to tell whether it is terminating or non-terminating repeating. So you have found out it is terminating. So that is the answer. That's it. Stop. But how many places of decimal this will have?
5.
It will have 5 places of decimal. Okay. So now let's get to the third question. 64 by 455. So when you did the prime factorization of 455, what do you get?
5 into 131.
Okay.
Oh God.
Sir, 13, 7.
Yeah, so basically you should have tried with 7. Okay. So the decimal expansion is what? 5 into 7 into 13. So now, before we decide that, okay, 7 and 13 have come here, so it means it is non-terminating repeating. But before you write the final answer, just quickly just check the numerator. Is there any way to cancel this 7 or 13 from the numerator? So in this problem, it's 64. It cannot be cancelled with 13 or 7. That means it will be, the decimal expansion of this number will be non-terminating recurring, which they are calling it as repeating. Is it clear? Hari?
Yes, sir. Yes, sir. So there only I was time count.
Okay. Okay, anyone needs help with any other questions? Okay, check this 8th question. What kind of expansion this will have?
Terminating.
Okay, Charan says terminating. What about other people?
Terminating. Sir.
Terminating, sir.
Yes. Why? What happens? Even though there is a
3 can be
Three
Sir,
can
you can cancel it, sir.
yes, there is a 3 over here, but we know that it can be cancelled with this. So it becomes basically 2 by 5, and now it becomes of the form 2 by to the power m, 5 to the power n. So this will have a terminating decimal. So now I think you people are experts. You will be able to always decide whether it has a terminating decimal or non-terminating. You also are smart enough. You will check quickly before deciding. If something else appears, make sure, check it whether can I cancel with the numerator. So you should be smart about it. Don't just blindly. Okay, I just see 3 over there. Just blindly I will write non-terminating. You shouldn't do that. Okay. Be careful. Look at the numerator. Can I cancel that thing or not? Always. Okay. So next question. Write down the decimal expansion of those rational numbers in question 1 above. Okay, yeah. So this is basically, you have to go to the same question and write down the decimal expansion of all these numbers. So you've already done
Sir,
the
of which are terminating, sir?
uh-huh.
Which and all are having terminating, for that only we should write, sir.
Yeah. Which have terminating decimal. Not all of them. Because the ones which have non-terminating repeating decimal, there is no other go, but you will have to do division. So doing division is not, if your numbers are like this big, it will take half an hour for you people to complete the division. So of course, only for terminating decimals, you will do the decimal conversion. Okay. Fine. So question number 1 and 2 we are done with. What about the third question? What does it say? You will do this in home. You will complete this in home. Okay. Third one. What does it say? The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. Yeah. So quickly tell me. Look at this decimal number and tell me whether it is rational or irrational.
Rational, sir.
Rational, sir.
Yes. Why? Why is it rational? Because
Terminating.
it has a terminating decimal. Yes. So any terminating decimal number can be converted to E by Q form. I can just remove this decimal, and in place of decimal, I'll put a 1. And how many ever digits are there, that many zeros I will put. So it will become P by Q form anyway. But anyway, you don't have to do that. So, but you should know that it can be done. Second one. What about this second one?
Non-terminating.
Non-terminating.
So this is non-terminating. That is true. But is it rational or
Irrational,
irrational?
sir. Irrational. Non-terminating, non-recurring.
Non-recurring,
This
sir.
is non-recurring. It is 120, 1200, 12000. So this is, it has a pattern. It is not repeating. So it is an irrational number. Okay. What about the third one?
Non-terminating.
Non-terminating and repeating.
Repeating.
Okay. So
Rational, sir.
so it is rational number again. This was rational. This was irrational. Okay. So that's it then. We are done with this chapter. So in your next class, which will be on Monday, over this weekend, you will go through this whole chapter. You will try to revise everything, okay? So on Monday, I will give you some questions completely from everywhere, all these, whatever we learned in the first chapter, I'll give you a question from everything, okay? So you should be prepared for that. It will just be a class work. You'll do this in your class. It will not be like a test, but make sure you revise all types of questions which we learned in this chapter over the weekend, okay? And soon we will have a test for this first chapter also.
Sir, tomorrow's tuition is there, sir.
No, tomorrow you will not have class. The class will be on Monday now. Okay. So
Okay, sir.
anyone has any doubts? Whatever we studied now? No.